right, well, we'll go ahead and get started now. I'd like to thank everyone for attending. My name is Nathan Childress with Mobius Medical Systems. We're the makers of DoseLab Pro. And I'm going to start off today's webinar with a short presentation, and then we're going to get into using the software and seeing how it can be used for machine QA and film dosimetry. If at any time during this webinar you have any questions, please type them in the questions box shown below. And we're going to go ahead and answer all questions at the end of the session, so don't worry if we're not answering them right away. You can type them in whenever you have them, and then we'll pause and answer all questions. So, what is DoseLab Pro? DoseLab is simple, fast, and powerful software that's used for TG142 Linac QA, TG142 machine QA, film dosimetry, automatic dose comparisons, statistical analysis of previous dose comparisons. One of the really nice things about DoseLab Pro is that it's licensed per site. So no matter how many Linacs you have, no matter how many computers you would like to install it on, one license covers your entire clinic. All routines in DoseLab Pro use some very advanced image processing techniques. This results in very fast results, very reliable results, and results that are very reproducible. All routines also export to PDF and XLS, so that way, after you do all this QA, the documentation is a built-in step within DoseLab. So just a real quick rundown of the features DoseLab has, and we'll show these in the software later on. For routine QA, it will do star shots, Winston LUTs tests, MLC positioning and skew, flatness and symmetry with light rad field, VMAT routine QA, and edge-on PDD exposures. It also has some other useful tools like image combination, PDF combination. It will automatically transfer files from a Linac or treatment planning system. And all the routines are designed to meet the TG142 criteria. The really nice thing about the TG142 package is that these image processing routines are designed to eliminate image artifacts and noise from the analysis, so that way you can have all sorts of images and still get good, easily obtainable results. The imaging QA package offers full flatbed panel imaging QA for both MV and KV imaging. It calculates positioning offsets, contrast and CNR, uniformity, spatial resolution, image scaling, and it has support for all the popular phantoms. Plus, if you want to, you can add your own user-customized phantom. What's nice about the imaging QA is that compared to some other software packages, we can calculate a few more things, such as position offset because it brings in your reticule location, and we can also automatically calculate image scaling using the full 2D phantom size. It also has CT and cone beam CT QA. This package, which you'll see, is very, very nice. We analyze the images in a little bit less than 5 seconds. You have to take a CT scan with either a CAT fan or a GAMX 464 ACR accreditation phantom, but then it will calculate contrast, CNR, overall uniformity, and individual ROI uniformity, HU deviation, spatial resolution, image scaling, and slice width. And so as you'll see in the software, it's very easy to use. Some new tools in version 6.0, we've now added tolerance settings to all TG142 tools. So anytime you do a star shot, MLC strip test, you can set what your baseline is, warning, and failures. The colors of the results change to indicate whether it pass, warns, fail, as you can see on the bottom left. And PDF reports will also indicate whether each result passed, warned, or failed. DoseLab also has a new internal TG142 database. You can see a graph of this in the lower right. It also features full exports to Sun Nuclear's Atlas database. The DoseLab internal database is designed to do one thing very well, very quickly, and that's display trends. And you'll see how easy this is to use in actual clinical use. It also shows tolerances and baselines. So all of that was the DoseLab TG142 package. The full DoseLab Pro package adds film dosimetry and automatic comparisons. And film dosimetry is very important because you can get high-resolution results. It can be used as your primary. Most people are now using that as a secondary IMRT QA system. With the popularity of map check devices, film is now, maybe if map check fails, you might want to do film. It has to be used for IMRT and VMAT commissioning. The DoseLab Pro film dosimetry package supports custom film phantoms. They can have localization fiducials or not, it doesn't matter. It supports EDR2 and EBT2 films, and all of its dose comparison results are saved either for individual viewing or batch analysis using PQI analytics. The film dosimetry package has very fast film calibration. It has support for VIDAR and Epson scanners. It does uniformity corrections on both of those scanners. It does EVT2 film blue channel corrections, and it uses a Weiner filter to remove some noise. The automatic comparisons in DoseLab Pro, as you'll see, takes about 5 seconds per comparison. And what we'll do is read in all the images and flip and rotate them, select ROIs, align the two images, calculates dose normalizations, gamma, extracts profiles for PDF reports. It saves all the results, and it generates a full PDF report in less than 5 seconds per comparison. This saves a huge amount of time for high-volume clinics. The nice thing about automatic comparisons is that they work with measurement arrays like MapCheck, the IBA's matrix. They work with film or EPID images, as long as you have an external portal dosimetry software to convert the EPID images into dose, like Nuclear's EPIDose. The other nice thing is, since DoseLab saves all of its IMRT-QA results, we can go back with PQI Analytics and analyze them in just a couple clicks. And you'll see we can analyze them as a function of different QA machines, different energies, etc. We can also calculate new gamma results on the fly for new dose or distance criteria. So, DoseLab licensing is available in 2 packages. DoseLab TG142 includes all the Linac QA, Imaging QA, and Machine QA database. And DoseLab Pro adds the film dosimetry, automatic comparisons, and PQI analytics. It's licensed to each physical site and can be installed on any Windows PC. It can also be installed on a shared drive, and of course at an unlimited number of computers at each site. So, in summary, DoseLab increases the reliability of your QA routines and saves you time. It's an all-in-one tool for Linac QA, Imaging QA, IMRT QA, and it's designed for the modern radiation oncology clinic. We really put a lot of focus on supporting EPID images, IGRT tests, Winston-Lutz tests, and make sure everything exports to PDF for a lot of time savings. So, again, I'd like to remind you, we're going to start a software demonstration now. If you have any questions, please type them in the questions box. So, here is the new DoseLab Pro version 6 interface. You see we have easy access to all of its tools, and we're going to start off showing you the DoseLab TG142 package. So I'm going to start with single image analysis, and this is a nice tool because it lets me bring up images before I actually use the machine QA tools. So if I need to make any edits to them, it's very easy to do. It has a full suite of editing tools, it has some built-in simple analysis tools, and then it also has specialized machine QA routines. So here I pulled up a flatness and symmetry film. Most clinics prefer to use EPID. I'm going to go into machine QA, flatness and symmetry, and I'm going to make sure I select my base profile, and I will tell it that the image has light field marks. This way, even though this film doesn't actually have light field marks on it, I can click where the light field marks are, and DoseLab Pro will automatically calculate the light radiation field offsets. You do need to mark your film or your EPID image. And here's a result using DoseLab's tolerances. You can see my horizontal symmetry, vertical field size, horizontal max value, and max horizontal differences all generated a warning. And this is because, as you can clearly see, the blue profile, what I measured today, does not quite match the red profile, which is my base profile. So my symmetry, my flatness are off a little bit horizontally, and that's displayed very clearly in the warning results box. Here we see it calculates all the flatness symmetry, parameters, max vertical difference from baseline, horizontal difference from baseline, field size, how much the field size is off from where it should be, vertical min-max, horizontal min-max. The really nice thing about DoseLab is all of these tools export to PDF. So in one click, I click File, Export to PDF, type a name, and I have a really nice report. Here we can see the summary. There's some test generated warning. Most tests pass. These few generated warning. We have base profiles, measured profiles, and another nice thing about DoseLab Pro is every time I do image processing, we show the results of the image processing on top of your original image, so you have confidence that everything worked well. Here you can see red lines are the field edges, blue lines are the extracted profiles. So let's move on to some more machine QA. Let's look at the MLC strip test. Again, this is done with either film or EPID. We go into our MLC strip test tool, and you see we can change our threshold settings. Most of the time we just need to open this and click process. It goes through and does a Gaussian peak fit of all of these MLC strips. Here you can see everything passed. And most of the time in clinical use, all your MLC tests do pass. So we need to get good results for even tests that are already passing. That's why we calculate the standard deviation of the curve fit. We calculate maximum deviation. And what's really nice is the distances between the lines and the slope of the lines. Here we can tell that my MLC is moving as it goes from one side to another within about 0.03 of a millimeter, the same each step, and that it's not skewing as it goes from one side to another. We see only about a 0.02 degree difference in each of the slope of the lines. A lot of clinics will expose this middle strip using the main jaws, and that way they can test the skew of the MLC and the alignment of the MLC relative to main jaws. Again, that can export to PDF or can export to Excel. Now let's open a Starshot test. This can be done with usually film. You can also do collimator Starshot tests with EPID, manually adding the images up yourself with our Combine Images tool. So if we have our ISO center marked on the film, we can say we'd like to compare the optimal center to where I first click. In this case, we don't, so we'll just click Process. Click near the center of the image. Click a circle that goes through all the legs, and here you see all tests pass, and we have one clear result, the diameter of the circle touching all the spokes. It's about 1/4 of a millimeter. This is very reproducible, very easy to use. And here we can see a larger plot showing each individual leg and the circle, the smallest circle that can be drawn that touches all legs of the Starshot. Let's go ahead and move on to let's go do some imaging QA. Let's look at a, this is an MV image of a standard imaging phantom. We'll go here and choose MV and KV imaging. Notice it's the same tool for both MV and KV. All we have to do is select the phantom that we're using. In this case, it's the QC3. Click Process. And DoseLab goes through, automatically detects the phantom, and calculates all the parameters we talked about earlier. Here you can see it uses a reference image, and the evaluated image is compared to it. We find the edge of the phantom. We compare the phantom size of evaluated to reference to get the scaling discrepancy. We also use these line pairs to calculate spatial resolution. We look at uniformity, contrast, CNR, and again, because we bring in the reticule location, we get positioning offsets. Let's go ahead and transfer this to PDF. And again, you'll see we have nice clear results. Here, all tests pass. Here's our MTF plot, a list of all the major results, and the original image. So we can do the exact same thing with KVQA. Here I'll show a Leeds phantom. This comes with most Varian and Electa machines. We'll go into Machine QA, MV KV imaging. The only thing that changes is we select the Leeds TOR 18FG. Click Process, and it goes through the exact same routine. It's determining the magnification, it's placing the ROIs, doing all the calculations. And again, here you see we have nice, easy results. We can always add a note to any of these results. We can save the results to the database and view the database or change the preferences. Let's go ahead and real quickly do Winston-Lutz film just to show you the difference. Here, if we have film, we can do a Winston-Lutz analysis. We manually add ROIs because film can have a lot of writing, so that way we get to preserve the writing but pick which ROIs we would like to see. What most people more commonly do nowadays is they use their EPIDs to do Winston-Lutz tests. This is good not only for stereotactic treatments, but it's also good for IGRT alignment tests. You can actually use your IGRT system to position your Winston-Lutz phantom and get results. That's exactly what I did for these 4 EPID images. So here, in multi-image Winston-Lutz, I can select all 4 images, click Open, and in about 1 second, it analyzes the images. Again, it shows me they're out of tolerance. My maximum difference is 1.3 millimeters, and failing is 1 millimeter. So in this case, I expect my Winston-Lutz difference to be a little bit higher than normal because this is my entire end-to-end IGRT alignment test. But again, you can see how this is the same Winston-Lutz interface. It just automatically calculates all the regions of interest. We don't have to manually do anything when we're using EPID images. We have very clear results. We also have VMAT QA. This is the monthly test that Varian recommends, although it can also be done for elective machines. We take an image of our open field using our EPID, and then in rapid arc mode, in VMAP mode, we'll deliver these 7 strips. All these strips have different dose rates and gantry speed, and the goal is that even though we're using much different settings, we're delivering the same number of MU to each strip. And so we look at the ratio of these strips individually, and they should be 1 plus or minus 2% as variance tolerance. And here we can see that the highest deviation we have is 0.7%, so this test passes. We can also do the same test with MLC leaf speed. That just uses slightly less strips, but it's the same analysis, same using your EPID to collect 2 images and automatically doing the analysis in DoseLab. Finally, the last imaging QA tool I'll show you is Cone Beam CT. And this is very, very nice. Let's go ahead and do a CAT fan example. All we have to do is select the folder that has the DICOM images. It loads the images, and it automatically analyzes them. In this case here, we still have it set to GAMX. We'll change it to CAT fan. It reanalyzes the slices, and there are our results. Here you can see we have modules for our HU deviation, for slice width determination. We have most of the same results that we have for our KV and imaging QA, except now that at CT we add maximum HU deviation and slice width. We also give you results for the uniformity details. You can see exactly how uniformity changes as we go from the middle to the outsides of the phantom, and HU constancy details. Here is the module that has our spatial resolution in it. And again, we can always file, export to PDF. We can view an MTF plot, change preferences, save this result to the database. So, speaking of which, let's look at the Machine QA database. This is a brand new feature in version 6.0, and it's designed to be very fast, very easy to use. Not only can you save results to DoseLab's internal database, but we now have full support for Sun Nuclear's Atlas version 1.3, which is not quite out yet. So we can export results one at a time to Atlas, or we can view them in DoseLab's database. Here, it's very easy to do. We simply select the machine we'd like to see, the test we want to see results for, and then some tests have subgroups. Flatness and symmetry groups them by energy, and you select the line you'd like to see plotted. Top flatness, bottom flatness, vertical symmetry, vertical min, all these parameters. If we'd like to look at our star shot tolerance for couch over the last 2 years, that's all we have to do. Select the machine, the test, the group. It clearly shows how many results we have. We have 1 asterisk if it warns, 2 asterisks if the test failed. So very easy to use interface to save all your results and analyze trends very quickly, very easily. So that's the end of DoseLab TG142. I'd like to take a couple minutes and show you some film dosimetry tools and the full dose comparison package. Here we'll start off with a flatbed scan, and what we do is we scan a blank film so we can do a 2D uniformity correction, and then we can add our calibration film and our measurement. The wedge film calibration tool is very fast, very easy to use. It's designed to work with both physical wedges and dynamic wedges. This is a Varian dynamic wedge. It takes about 30 to 45 seconds to expose the calibration film. It just takes a few seconds in software to analyze it. So we have a nice film calibration with 50 points with very minimal time. And then applying the calibration is quick and easy. Loads up the last calibration. We select our measurement. And again, here we have our EBT2 blue channel correction is automatically applied, and our Weiner filter is automatically applied to remove noise. So in less than about 30 seconds, we can go from a film scans to dose with a lot of corrections in between. It's designed to be very easy to use. After we've converted our film to dose, we can use DoseLab's automatic comparisons to analyze them. In this case, I'm just going to show what map check comparisons look like. We have an automation menu, so we can do as little or as much of these steps manually as we would like, and we'll change our output options to the batch comparison preset. And here we get to customize which screens are shown in PDF and which screens are shown in the display. Here for batch comparisons, we're not actually going to show any screen except the final PDF report. So what's nice is this example is from Pinnacle. We have 5 Pinnacle files. Click Open. It's already detected that we have previous results. We'll go ahead and rerun the comparison instead of displaying the previous results. And it's already found that we have 5 map check images. So all that's left for us to do is click Next. It loads all 10 images. We have calculated on the left, measured on the right. We need to go through, make sure they're all the same image. They obviously need to be rotated and aligned. DoseLab will take care of that. And after we click Next, all of our IMRT QA is done automatically at this point. It's going through calculating that long list of parameters that was displayed in the presentation. It's calculating gamma. It's doing an automatic alignment. And because MapCheck has its own coordinate system, DoseLab is going to compare its automatic alignment to the MapCheck coordinate system and give us offsets. So again, it's done extremely quickly. It's just going to show the PDF at the end. And here we go. Here's one PDF of our 5 MapCheck measurements analyzed fully automatically. You can see we have normalization factors, all within 1%, very high gamma passing rates, low net indexes, and then here's our X and Y offset. So very easy to use, and we can scroll through and then see the results of each of these 5 comparisons, profiles and gamma image. And what you put in these comparisons are, of course, fully customizable. Now, after you've done with, after you've been doing IMRT QA for a year or two, you'll probably want to go back through and analyze all of your results. That's where PQI Analytics comes in. Here we can select, this is the example folder with 30 dose comparisons. We tell it to analyze the percent of pixels passing gamma using 3% 3mm as a function of different QA machines. Click Process. And again, here are our results. It found 2 machines, machine 1 with 15 data points, and machine 2 with 15 data points. We see machine 1 has a higher percent of pixels passing gamma and a tighter spread than machine 2. So if this were actual clinical data, we'd want to look at machine 2 and maybe do a few more tests on it, make sure it's performing as well as other machines are. If you want to evaluate, let's say using, for some reason, 6% 2mm criteria, let's make it just 2mm. Then you simply type the new criteria in, click Process, and it will go through, it will recalculate gamma results. You can tell it's going a little bit slower because it has to calculate gamma results, save them to a file, but then there are your new results. And finally, to finish off DoseLab, I'd like to just real quickly show you some of the other tools. We have file transfer, where we can set up Windows folders or FTP servers representing our treatment planning systems or EPID images on our Linux. So we have a one-click file transfer to our local computer. We can combine PDFs. You can see we have a flatness and symmetry and an MV PDF. Here we can add them once. Click Make New PDF. Call this monthly. And there's our flatness and symmetry and our MV imaging QA results in one PDF. We can do the same thing with images. Go to Combine Images. Here's our Winston Lutz images. We can either append them from left to right to make one image, append them from top to bottom. We can add them together. We can rescale them. Very easy to do. We can save a new image as a TIFF file, and we can also bring that up in single image analysis. And finally, we can rename DICOM files. If you have a DICOM export from your record and verify system, you're not quite sure what it exported because it's just a string of numbers, point DoseLab to that directory and tell it how you would like the new files to be named, and DoseLab will go through, rename all the files so you can easily see what you're analyzing. So that is really a brief summary of all the functions DoseLab Pro has. It has a full machine QA suite, full imaging QA suite included in the TG142 package. All the utilities are also included in TG142. And then the full DoseLab Pro package adds film calibration, adds the automatic dose comparisons, machine, and the PQI analytics. I'd like to thank everybody for attending, and please get in touch with your Sun Nuclear representative for more information about DoseLab Pro.